Welcome back to the deep dive, the place where we don't just scratch the surface of confusing topics. We take a shovel,
Yay.
dig deep, and really extract the essential, useful knowledge for you.
And today, we are tackling a nutrient that has spent, well, probably the last decade or so in the penalty box of popular fitness culture, the carbohydrate.
It's so true. Carbs, they are kind of the macronutrient non grata these days, aren't they?
Definitely.
If you open up social media right now, I mean, it's just a constant barrage of protein powders, keto recipes,
Oh, yeah.
and people treating anything involving grain or starch as if it were, fundamentally detrimental to their goals. We see this trend reflected constantly in the material we analyze.
It's everywhere.
And it's kind of wild because a nutrient that is absolutely fundamental for peak performance is constantly being villainized.
And the reality, which our sources make abundantly clear, is, well, it's far more nuanced, actually much, much more positive than you might think.
Right.
The core truth we are unpacking today is that carbohydrates are, without question, one of the most important nutrients for providing stable energy and ensuring optimal function for every single cell in your body.
Okay, so let's unpack this misconception then. If carbs are not the enemy, what is our mission for this deep dive? We've got an exceptional stack of source material today, haven't we?
We do.
Including expert opinions and data from great resources like bfit.ai, really emphasizing performance, biological necessity, and just practicality.
Yeah, exactly. So our mission is really twofold for you, the listener. First, we need to clearly define what carbohydrates actually are, moving past the basic food groups and getting a bit into the biochemistry.
Okay.
And explain exactly how they function as the body's primary fuel source. We're talking brain power for your job and sustainable energy for your training sessions. Second, and this is crucial, we'll show you the evidence-based strategies for choosing the healthiest sources, because that's the real differentiator here. It's true, not all carbs are created equal, and choosing wisely is absolutely essential for supporting pretty much every health and fitness goal you might have.
Perfect. Let's start right at the very foundation then, the technical definition. Because when most people hear carbs, they immediately picture, a plate of spaghetti or a slice of bread.
Right, the usual suspects.
But our sources confirm that carbohydrate is this enormous umbrella term covering several distinct chemical structures.
That's right. It covers sugars, starches, and fiber, all are macronutrients fundamentally. What's really crucial to understand here is that the difference between them basically boils down to their chemical structure and the length of their chains.
Okay.
And this structure directly dictates how quickly your body can actually access the energy stored within them.
Okay, explain that chemical mechanism for us. When we consume any carbohydrate, what happens next inside the body?
So regardless of the source, doesn't matter if it's a simple sugar from fruit or a complex starch from, say, oats, they all eventually break down in your digestive system into glucose.
Glucose, right.
Glucose is a simple sugar, technically a monosaccharide, and it is pretty much the universal currency of energy in the body. It's what powers your muscles, your internal organs, and maybe most critically, your central nervous system and your brain.
Why does that matter so much for the average person listening?
Well, because if you're focused on staying active, sharp, and just energized throughout a demanding day.
Which most of us are.
Exactly.
Yeah.
You are demanding high volumes of glucose. Your brain alone uses roughly 20% of your total daily energy intake, which is huge, and it runs almost exclusively on glucose.
Wow, 20% just for the brain.
Yeah, so if you deprive it, you start to compromise focus, memory, and just general cognitive performance.
Yeah.
Good carbohydrate intake is really non-negotiable for high mental output.
Okay, this leads perfectly into that classic distinction that I think generates so much confusion. Simple versus complex carbs. And as we learned from the critique, we need to go a bit deeper than just labeling them good versus bad here.
Absolutely. That's a really important point. The terms simple and complex are purely structural definitions. They relate directly to the length of the sugar chains. Simple carbohydrates are shorter chains, things like monosaccharides, glucose itself is one, and disaccharides, like lactose in milk, or sucrose, which is table sugar.
Got it. Short chains.
Right. Complex carbohydrates, or polysaccharides, are these long, often branched chains that just take much longer for your body to disassemble.
And this chain length is the key to understanding that energy curve people talk about, right? Like the spike and crash.
Precisely. Simple carbs, because they're already short chains, they break down into glucose extremely quickly. This leads to a rapid spike in blood sugar and a corresponding sharp insulin response from your body trying to manage it. This gives you that quick burst of energy, sure, but often it's followed by a subsequent crash.
Right.
And these include the natural sugars found in milk and fruit, but importantly, also the added sugars you find in lots of processed foods.
Okay, so let's talk about that nuance, because that's key. If milk and fruit contain simple sugars, how do they kind of escape the bad carb villainization that processed sugar gets?
It's all about that essential package deal you mentioned earlier. It's
Yeah.
so important. The sources really emphasize that milk and fruit come packaged with other substances that fundamentally change how that simple sugar is digested and absorbed.
F so.
Well, take milk, for instance. It contains protein and calcium. Both of those slow down the absorption of the lactose, the milk sugar.
Ah, okay.
And fruit wraps its simple sugars like fructose with lots of water and, crucially, fiber.
Fiber, right.
That fiber acts almost like a physical barrier. It slows down the whole enzymatic breakdown process in your gut, preventing that really sharp spike and crash in blood sugar you'd get from, say, drinking juice or eating candy.
That makes sense. Okay, now on the other side of the coin, the complex carbohydrates.
Right. Complex carbs are the starches and fiber you find in whole foods. Think oats, quinoa, pulses, which are things like chickpeas, lentils, edamame, and also vegetables.
The good stuff.
Pretty much. Because their chains are long and often intricately woven with fiber, they are digested slowly and methodically, much more gradually.
Okay.
The result is this nice, gradual, sustained release of glucose into the bloodstream. And that is exactly what we want for stable energy levels, for endurance, and just for long-term health overall. Choosing these complex, fiber-rich sources is really essential for performance.
This structure-function relationship brings us directly to the essential role of carbs in optimal health, moving past just simple energy provision and into the realm of actually feeling and functioning at your best.
Yeah, and we really need to underline the argument here from registered dietitian Daisy Mercer, who states pretty definitively that carbs are absolutely necessary to feel your best and achieve good health.
Absolutely necessary, not just optional.
Exactly. It's a requirement, not some kind of luxury you can just cut out. She says we need them to think our best and for many other bodily functions to work optimally. So restricting them, especially over the long term, really means compromising basic biological needs.
We've established that glucose fuels all cells. Let's drill down now into the three major kind of practical functions that get compromised when carbohydrate intake isn't sufficient.
Okay, function number one, advanced brain function. As we touched on, the brain is incredibly demanding energetically.
At 20%.
Right. It requires a continuous, stable flow of glucose, not just to, keep the lights on, but to execute high-level tasks effectively.
Like what kind of tasks?
Think strategic planning, learning a new skill at work or school, managing emotional responses, dealing with stress.
Okay, complex stuff.
Exactly. When that glucose supply is insufficient or it's unstable, maybe because you had a crash after eating refined carbs or you're intentionally restricting carbs, the brain just struggles. Our sources point out this is often why people report mental fog or difficulty concentrating when they first try very low-carb diets.
Right, I've heard that a lot.
Yeah. Maintaining that focus, supporting memory consolidation, managing complex decision-making, it's all fundamentally a glucose-driven process. So, stable, complex carb intake ensures a reliable fuel line straight to your most important organ.
Okay, function number 2 is perhaps the most ironic area where people restrict carbs, especially listeners focused on fitness, the active lifestyle. This is where that phrase hitting the wall really comes into sharp focus, isn't it?
Oh, absolutely. This is critical for anyone who exercises intensely. Carbohydrates are what replenish your glycogen stores, primarily in your muscles and liver.
Glycogen, define that quickly.
Glycogen is simply glucose that's been packaged up and stored right there in the muscle or liver, ready for rapid deployment when needed.
Got it, stored fuel.
Exactly. So if you are training, say you're lifting weights, running long distances, cycling hard, you are rapidly burning through these glycogen reserves. It's your high-octane fuel.
And what happens if those reserves actually run out mid-workout?
Well, if you hit true glycogen depletion, you experience that phenomenon often called bonking or hitting the wall. It's not just feeling tired. Your muscles literally cannot continue to contract effectively. Your energy levels just plummet dramatically.
Oof, sounds unpleasant.
It is. So carbs are essential for performance during activity, obviously, but they are equally vital for recovery afterwards.
Ah, the recovery piece.
Yes. Post-exercise, quickly replenishing those muscle glycogen tanks is absolutely how you ensure that you are recovered and ready for the next day's workout. It's key for maximizing strength gains, endurance improvements, everything over time.
So restricting the very fuel source you need means you can't recover properly, which kind of undermines the whole goal of being active in the first place.
Precisely. You're shooting yourself in the foot, metabolically speaking.
Ah.
And the third major function, which is getting a lot more attention these days, thankfully, is gut health.
Right, we're talking about fiber acting as a prebiotic here, feeding the good gut bacteria.
Yes, but let's understand the mechanism a bit better. Prebiotics are essentially non-digestible components of food, mostly specific types of fiber found in carb-rich plants. They specifically feed the billions, actually trillions, of beneficial bacteria residing mainly in your large intestine.
Okay.
And they don't just feed them passively. They enable these bacteria to ferment the fiber and produce highly beneficial compounds as byproducts.
What kind of compounds are we talking about?
The most important ones are called short-chain fatty acids, or SCFAs. The star player among them is usually butyrate.
Butyrate, okay.
Butyrate is a fascinating molecule because it actually serves as the primary fuel source for the cells lining your colon, the colonocytes.
Wow, fuel for the gut lining itself.
Exactly. So when you consistently feed your gut bacteria with these fiber-rich carbs, you help produce more butyrate, which strengthens the gut lining. This in turn helps reduce inflammation locally and systemically, improves overall nutrient absorption from all your food, and provides crucial support for your immune function, since a huge part of your immune system actually resides in or around the gut.
That's incredible.
So healthy carbs are actively managing your internal ecosystem, providing benefits far, far beyond just muscle fuel.
That is really powerful context. It definitely elevates the humble lentil or bowl of oatmeal far beyond just a simple food source.
Okay, now that we understand the absolute necessity of carbs for optimal function, brain, muscles, gut, we need to address the most common question people have. How much do I actually need? Let's try and put some robust numbers to this need.
Okay, so we can start with a general recommendation provided by the Dietary Guidelines for Americans. For the average adult, carbohydrates should make up about 45% to 65% of your total daily calories. 45 to 65%. That sounds like a lot, especially given the current trends, and it's pretty wide range, too.
It is a wide range, and yes, it often surprises people how high that percentage is. It covers everything from someone with moderate activity levels right up to high-level endurance athletes.
Okay. And when we translate that wide percentage range into actual grams of food you might eat, what does that look like?
Well, doing the math, it means the average adult needs somewhere between roughly 130 grams and 390 grams of carbohydrates per day.
Wow. Okay, the difference between 130 grams and 390 grams is vast. Why such a wide range there? What accounts for that huge difference?
It really just reflects the sheer difference in individual caloric demands and metabolic function. Someone aiming for, say, weight loss, who has a relatively sedentary job, will likely be towards the lower end of that 45% range, maybe needing closer to that 130 or 150 grams.
Okay.
Whereas an individual training hard for a marathon, or maybe a larger person engaging in intense physical labor all day, they're going to quickly push up toward that 65% mark, needing maybe 300, 350, even that 390 grams or more.
So the main drivers are things like age, sex, body size, and especially training intensity or activity level.
Exactly. Those are the primary variables. You'll find that children, larger adults, and the highly physically active consistently need to aim towards the higher end of their personal range.
Okay, to give this a more concrete context for people listening, let's use the specific data points we have available from the sources. Show us exactly how those calorie demands translate into required grams for different groups. Let's start with, say, the younger, typically more active demographic.
Sure. Let's take adult females, maybe between 19 and 30 years old, consuming an average of, say, 2,000 calories a day, based on that 45-65% range.
Yep.
Their carb intake recommendation falls somewhere between 225 grams and 325 grams per day. That amount generally ensures their brain and muscles are well fueled for moderate activity without providing excess energy.
225 to 325 grams.
Okay.
Now compare that to an adult male in the same age bracket, 19 to 30, who often has a higher baseline caloric need, maybe around 2,400 calories daily on average.
Right. For him, that requirement jumps significantly. He'd be looking at somewhere between 270 grams and 390 grams of carbs per day.
270 up to 390.
Yeah, and if you look at that upper end, that 390 grams, it really confirms that if you're highly active, if you are frequently depleting those glycogen stores we talked about, you simply cannot afford to skimp on quality carbohydrate intake.
All right.
Trying to run a 2,400 calorie engine on, say, 150 grams of carbs, it's just going to lead to performance failure, poor recovery, and likely chronic fatigue over time.
That makes total sense. And let's contextualize that high activity recommendation against maybe a demographic with lower overall caloric needs.
Okay, good comparison. Let's consider adult females aged 51 and older. Their daily caloric need might be lower, perhaps around 1,600 calories per day, depending on activity, of course.
Okay.
For them, their recommended range appropriately shifts down to about 180 grams to 260 grams of carbohydrates per day.
Still a significant amount, 180 to 260.
It is. It's still a substantial portion of their diet. Remember, it's still that 45 to 65% of their 1,600 calories. But the total volume, the absolute gram amount, changes drastically compared to the younger, more active male example.
So the crucial point here remains. The percentage of total energy that should come from carbs is relatively stable across different groups, reflecting that fundamental biological necessity for glucose as fuel.
Exactly.
The absolute gram amount simply changes based on the total volume of fuel required for that particular person's size and activity level.
That's the key takeaway on quantity. These numbers help us understand why extremely restrictive low-carb diets, those aiming for maybe 50 grams or less per day, are often metabolically unsustainable for many people in the long run.
Right.
Especially for those who rely heavily on cognitive function for their jobs or engage in regular, intense physical activity. You're literally underfueling the system for the work required.
This analysis provides the perfect transition now into, well, Section V of our deep dive. Choosing wisely. We've established that we need carbs, and we have a good idea of how many we need, roughly. Now, we must focus intensely on the quality of those carbs. Because, as you noted earlier, while sure, a sugary donut technically provides energy,
Right, it gives you calories.
it is definitely not what we'd call a healthy choice.
No, and this is where the value proposition idea comes in. Healthy carbs. We're talking whole grains, fruits, vegetables, and pulses. They offer so much more than just raw energy. They are comprehensive nutrient packages.
What's in the package?
Well, they come loaded with essential vitamins, minerals, that all-important fiber, antioxidants, and various beneficial plant compounds, phytochemicals, that actively support long-term health and protect your cells.
Okay, contrast that package with the default modern diet, which, let's be honest, often leans pretty heavily into refined carbohydrates.
Yeah, it really does. Refined carbs. Things like white bread, most bagels, pastries, sugary breakfast cereals, white pasta, white rice. They're manufactured using processes that deliberately strip the grain of its most nutritious parts, the bran and the germ.
Why do they do that? For texture? Shelf life?
Often both. Removing the bran and germ creates a finer texture and extends shelf life because the healthy fats in the germ can go rancid. But the nutritional cost is huge.
Where it gets lost.
You lose most of the fiber, the B vitamins, the iron, magnesium, vitamin E, those healthy fats. Basically, you're left with largely just the starchy endosperm.
Just the starch.
Pretty much. The result is a carb source that digests very quickly, converts rapidly to glucose, often spikes your blood sugar, but provides very little in terms of long-term nutritional benefit or satiety. So our advice, based on the sources, is simple.
Yep.
Be actively mindful of choosing whole, intact sources over refined ones whenever possible.
And the centerpiece of making that quality choice, according to all our sources, seems to be focusing on fiber.
Absolutely. We have a great quote here from Melissa Yeager, a registered dietitian and licensed dietitian, who really emphasizes that we must focus on fiber-rich carbohydrates for a nutrient-dense energy source.
Nutrient-dense, okay.
That will help keep you full, longer, and provide longer-lasting energy. Fiber is like the metabolic governor, you could say. It slows down that energy release from carbs and significantly promotes feelings of fullness or satiety.
Okay, let's dedicate some serious time now to diving into the specifics of these healthy carbohydrate sources that really deliver on this comprehensive promise, starting with what many consider the gold standard, whole grains.
Right, whole grains. Now, to be officially classified as a whole grain food, the product must contain all three original parts of the grain kernel. This isn't just a casual term. It's often a regulated definition on food labels.
All three parts, what are they?
You have the bran, the germ, and the endosperm. If either the bran or the germ is removed during processing, it legally becomes a refined grain, and as we said, the nutritional value just plummets.
Okay, let's detail the contribution of each component, because I think this really illustrates why that refinement process is so detrimental nutritionally.
Sure. So the bran is the tough, fibrous outer layer of the kernel. This is where you find the bulk of the dietary fiber.
Okay, fiber central.
Exactly. But it also contains important B vitamins like thiamine, riboflavin, niacin, which are crucial cofactors for energy metabolism itself, plus iron and various antioxidants.
Got it. Bran, ample fiber, B vitamins, minerals. What about the germ?
The germ is the nutrient-rich embryo or core of the seed. It's the part that would actually sprout into a new plant. And nutritionally, it's a powerhouse. It's packed with more B vitamins, vitamin E, a potent antioxidant, crucial trace minerals like magnesium and zinc, and healthy unsaturated fats.
Okay, lots of micronutrients and healthy fats there. And the endosperm, what's left?
The endosperm is the largest part of the kernel, and that's predominantly where the complex carbohydrates, starch, and some protein reside. It's the main energy supply for the seed.
So in a whole grain, you get all three working together.
Precisely. And because that fiber-rich bran is intact, and you have the fats and nutrients from the germ, the whole grain requires significantly more time and digestive energy for your body to break down compared to the refined version, which is mostly just that easily accessible endosperm starch.
The benefit, then, is that slower, more sustained energy curve we talked about.
Exactly. It's the difference between, say, throwing a handful of dry leaves or kindling on a fire versus placing a solid, dense log. The whole grain is the solid log.
Nice analogy.
It provides that gradual, steady release of energy, preventing the blood sugar volatility, the spikes and crashes that you often get from refined grains. Moreover, the combination of fiber and the small amounts of protein found naturally in whole grains really maximizes satiety. They help you feel fuller for longer on fewer calories, which makes them an excellent tool for appetite management and maintaining a healthy weight.
So practically speaking, we're talking about things like brown rice instead of white, quinoa, whole wheat bread or pasta instead of white, oats especially steel-cut or rolled oats, and maybe barley as essential staples to include.
Absolutely. Those are prime examples.
Okay, now let's move on to fruits. This is another source of, I think, considerable confusion because of the natural, simple sugar content. Despite their obvious health benefits, people worry about fruit being high carb.
Yeah, that fear of fruit's high carb count, or its sugar content, is, for the vast majority of people, largely unfounded and often counterproductive. Our sources are pretty emphatic on this. Most adults would actually benefit significantly from eating more fruit, not less.
More fruit. Okay.
While it's true that the natural sugar in fruit, mostly fructose, which is a simple carb, is present, the absolute key, again, is the package deal.
The package deal.
Fiber and water.
Exactly. Whole fruit comes naturally packaged with significant amounts of water, which makes it hydrating, and crucial dietary fiber. As we discussed, that fiber slows down the absorption of the fruit's natural sugars, leading to a much more moderate impact on blood sugar compared to, say, fruit juice or sugary snacks. Plus, the water and fiber together make whole fruit surprisingly filling. I understand the fiber benefit of eating a whole piece of fruit, say an apple, but let's press on this nuance a bit, because I know many listeners are thinking about smoothies today. If I make a smoothie and use a really high-powered blender, does pulverizing the fruit fiber like that fundamentally change the glycemic response compared to just eating the whole apple? What do our sources suggest about liquid versus whole fruit intake in that sense?
That is an excellent and very practical question. It really highlights the importance of the physical matrix of food, how it's structured. When you chew and digest whole fruit, the plant cell walls remain relatively intact as they enter your stomach and small intestine. Your body has to actively work using enzymes and mechanical digestion to break down those walls and free the sugars.
Okay, requires effort.
Right. And even the soluble fiber, though it forms a gel, still slows down gastric emptying and interacts with absorption in the small intestine. Now, when you blend a fruit very aggressively, especially in a high-speed blender, you essentially pre-process those cell walls. You rupture them mechanically, making the sugars inside almost immediately available for absorption as soon as they hit your digestive tract.
Oh, okay. So even though the total amount of fiber content might technically be the same in the smoothie versus the whole fruit,
Right, you didn't remove it.
the fiber's function as a physical barrier slowing down digestion is significantly reduced or altered.
Precisely. This generally means that the blended fruit will produce a faster and potentially slightly higher glycemic response, a quicker rise in blood sugar compared to eating the same amount of whole chewed fruit.
Okay.
Now, it's usually still going to be a more moderate response than, say, drinking pure fruit juice, which has virtually zero functional fiber left, or eating refined sugar. But the takeaway is pretty clear. For maximizing stable energy levels and satiety benefits, consuming whole fruits is always going to be physiologically preferred over blending them.
That's a great clarification. Smoothies aren't bad, but whole fruit is likely better for blood sugar management.
Exactly. Smoothies can still be a good way to get fruit intake up, especially if you have protein or fat sources, but be aware of that difference.
Got it. Okay, beyond just energy and fiber, what other protective benefits are fruits offering us in that package deal?
Oh, huge benefits. They are absolute powerhouses of essential vitamins like vitamin C and minerals like potassium.
Mm-hmm.
But also, they're packed with a diverse array of polyphenols and other antioxidants.
Antioxidants. What do they do again?
These compounds actively help combat chronic inflammation throughout the body and protect your cells from oxidative damage caused by free radicals. Think of them as cellular bodyguards. Different fruits boast different profiles of these beneficial compounds. That's why you see recommendations to eat a rainbow of fruit colors.
Get variety.
Exactly. Including a wide variety of fruits helps ensure you get a broad spectrum of nutrients and protective compounds that are often seriously lacking in diets heavy on processed carb sources.
Makes sense. Okay, moving on to vegetables, which I think we can all agree are pretty much the cornerstone of any healthy eating plan. Our sources categorize them broadly as starchy versus non-starchy. Let's talk about that.
Right. Vegetables across the board are fantastic because they're generally low in calories relative to the sheer volume of nutrients they provide. They're very nutrient dense.
Okay.
Now, the starchy vegetables, think potatoes, sweet potatoes, corn, peas, winter squashes like butternut or acorn squash. They naturally contain a higher concentration of carbohydrates compared to their non-starchy cousins.
So they provide more energy per serving.
They do, but, and this is key, they're also incredibly rich in other needed nutrients. Sweet potatoes, for example, are a spectacular source of beta-carotene, which your body converts to vitamin A, essential for vision, immune function. They also provide potassium, fiber. They're really dense fuel sources that absolutely should be included as part of a healthy carb intake. Don't fear the starchy veggies.
Good advice. And the non-starchy varieties. What falls into that category?
These are things like leafy greens, spinach, kale, lettuce plus broccoli, cauliflower, Brussels sprouts, bell peppers, zucchini, cucumbers, tomatoes, onions. The list is long.
The bulk of the produce aisle, basically.
Pretty much. These vegetables are characterized by being very low in total carbohydrates and calories, but conversely, they're immensely high in bulk-adding fiber, water content, and essential vitamins and minerals like folate, vitamin K, vitamin C, depending on the specific vegetable.
And what's the particular benefit of focusing on these non-starchy types?
Because of this combination, low calorie count, high fiber, high water content, they're uniquely beneficial for promoting satiety, helping you feel full and satisfied without consuming a lot of calories. This makes them incredibly valuable for weight management. And the high fiber content also contributes significantly to excellent blood sugar control. They add bulk and nutrients with minimal impact on glucose levels.
So load up on those. Got it. Finally, let's cover a couple of often overlooked or perhaps misunderstood carbohydrate sources. Milk, yogurt, and pulses. Starting with milk and yogurt, they contain lactose, which is a sugar. Should that simple sugar content worry us?
Again, we need to circle back to that whole picture or package deal perspective. Yes, lactose is a naturally occurring simple sugar, a disaccharide specifically, but milk and yogurt delivered alongside a valuable trifecta of high-quality protein, calcium, and often potassium.
Protein, calcium, potassium.
The protein in particular helps to slow down the digestion and absorption of the lactose, mitigating a rapid blood sugar spike.
Right.
And these foods, as a package, are invaluable for supporting bone health, thanks to calcium and often vitamin D fortification, muscle maintenance and repair, protein, and even heart health, potassium.
Right, so the context matters immensely, and if we're choosing yogurt specifically, any tips there?
The general recommendation is to choose plain, unsweetened versions and typically non-fat or low-fat options, primarily to minimize intake of added sugars, which are very common in flavored yogurts and saturated fat.
Plain is key.
Yes. And as a bonus, many yogurts contain live and active cultures, those beneficial probiotic bacteria we talked about earlier in the context of gut health, which can further aid digestion and support a healthy gut microbiome.
Good point. Okay, now for what I personally consider maybe the true superstar food group within the carb category, especially for the active learner looking for nutritional efficiency. Pulses. Define pulses for us again.
Pulses are the edible seeds of plants in the legum family. This group specifically includes beans, like black beans, kidney beans, pinto beans, lentils, red, green, brown, chickpeas, garbanzo beans, and dry peas.
Okay, beans, lentils, chickpeas, peas. Got it. Why are these superstars?
They are unique because they offer this fantastic and quite rare combination of high amounts of complex carbohydrates and significant plant-based protein all in one food.
Carb and protein together.
Exactly. This pairing makes them an extremely satiating, meaning, filling, and long-lasting energy source. You get the slow burn energy from the complex carbs and fiber, plus the added fullness factor from the protein.
How does their specific structure provide such powerful metabolic benefits beyond just being filling?
Well, the fiber content in pulses is exceptionally high, often containing both soluble and insoluble fiber, which dramatically slows down overall digestion and glucose absorption. But what makes pulses truly sophisticated metabolically is the significant presence of resistant starch.
Resistant starch. We hear that term sometimes. What is it exactly?
Resistant starch is a specific type of carbohydrate that, as the name suggests, physically resists digestion in your small intestine, where most carbs are broken down and absorbed.
So it basically bypasses that initial breakdown process entirely.
Largely, yes. It travels down to the large intestine essentially intact, much like fiber does. Once it gets there, it acts as an incredibly potent prebiotic fuel source for your gut bacteria.
Ah, so it's feeding the gut bacteria way downstream.
Exactly. It's feeding them much later in the digestive process, long after other carbohydrates from the meal have already been absorbed into the bloodstream. This slow, late-stage fermentation process in the colon is thought to be a major reason why pulses are so effective at stabilizing blood sugar levels, both immediately after the meal and even longer term, helping to prevent those post-meal energy crashes better than almost any other food group.
Wow, that is exactly the level of deep dive insight we were looking for on this. That's fascinating. And we actually have compelling scientific evidence to back this specific mechanism up, right?
We absolutely do. Our sources specifically cite a large, comprehensive analysis, a meta-analysis that looked at the results of 65 different intervention studies.
65 studies, okay.
And it unequivocally found that regular consumption of pulses led to significantly better post-meal blood sugar control and better long-term blood sugar control markers, like HbA1c, in people both with and without type 2 diabetes.
That's huge.
Yeah.
Better control for everyone.
Yes. It strongly supports the idea that this mechanical action, particularly the resistant starch component, is a powerful metabolic tool that most people can benefit from harnessing.
That is hugely persuasive evidence. So the practical recommendation is crystal clear. Find ways to incorporate more pulses into your diet. Think adding them to soups, stews, chilies, curries, salads, even making dips like hummus.
Absolutely. They are incredibly versatile, generally very affordable, and as we've seen, incredibly effective fuel.
Okay, let's start to bring our analysis full circle here, summing up the core learning from this deep dive.
I think the research and the expert consensus we've reviewed overwhelmingly confirm that carbohydrates are simply not the enemy they're often made out to be. In fact, they are vital, necessary fuel, especially for the most energy-demanding functions of both the brain and the body.
Right. So the essential takeaway for you, the listener, has to be making that critical distinction between the sources of carbohydrates. Stop fearing the macronutrient category itself.
Please do.
And instead, start actively prioritizing quality. Focus on getting the majority of your carbs from those nutrient-dense options we detailed. Whole grains, fruits, vegetables, and pulses.
If you prioritize those quality sources, you naturally maximize your intake of essential vitamins, minerals, antioxidants, and crucially, that all-important fiber. And by doing that, you ensure you have the stable, sustained energy required for high performance, whether that performance is cognitive at your desk or physical in the gym or on the trail.
So we've defined the fundamental need for carbs, we've looked at the recommended intake numbers based on activity, and we've clearly identified the best, highest quality choices. Here's a final provocative thought for you to consider as you reflect on everything we've discussed today.
Okay, let's hear it.
Given that we know complex, fiber-rich carbs, especially those with resistant starch-like pulses, are essential for maintaining stable blood sugar and for replenishing those muscle glycogen stores, which we know takes time after exercise, how might strategically timing your intake of specific, healthy carbs, think maybe cooked and cooled pulses or whole grains to maximize resistant starch, how might timing those around your intense physical activity potentially maximize your personal endurance during workouts and, maybe more importantly, enhance your recovery over multiple training days?
Ooh, that's getting into nutrient timing strategy. Thinking about not just what you eat, but when you eat it relative to your demands.
Exactly. How could playing with that timing optimize that long game of fueling and recovery?
That's a great question for people to ponder and maybe even experiment with carefully. Applying that kind of knowledge is definitely the next level of optimizing performance.
Indeed. Well, thank you so much for joining us for this really crucial deep dive into why carbohydrates are truly vital fuel, not villains.
It was a pleasure. Hopefully we cleared up some confusion.
And remember, if you are looking for more clear, practical, evidence-based fitness and nutrition knowledge to continue building your understanding, free resources like BeFit.ai are always available to help you cut through the noise.
Definitely check them out. Until next time, stay curious, stay well-fueled, and maybe focus on the fiber.
Great advice. Bye for now.